This video is a production of Wheels by Fleming of San Jose, California, USA, home of hand-built basic and replacement alloy bicycle wheels. I'm your host, Robert Shackelford, aka Fleming, aka Mr. Rabbit. Today's video category is technical information. Today's video title is Nipple and Thread Behavior, with a focus on how it influences effective rim diameter. When calculating a spoke length for a wheel that you're trying to build, one thing you have to do is you have to come up with a rim diameter. The hope is that the rim diameter that you come up with in the form of a number will turn out to be the actual effective rim diameter when the wheel is finally built. In other words, hopefully it worked. That's why we have the word effective and effective rim diameter. One thing you have to do when trying to come up with a rim diameter is you have to test the behavior of your nipples and the threads that you're using. In this video, I'm going to demonstrate that, first using box spokes with their factory threads on it with various nipples, and then again using spokes that came out of a spoke cutter and spoke threading machine with the same nipples, so you can see for yourself what happens when you change things. And then at the end, I'll relate it all to how it influences effective rim diameter and why it's important. The first 5 examples that follow of nipple and thread behavior were done using Ritchie Logic spokes to have approximately 9.5 millimeters worth of threading. Here we have a 10 millimeter low profile nipple from Echelon. Notice how far the spoke protrudes past the top of the nipple. Normally these nipples are used with double wall rims. Here we have a 10 millimeter standard profile nipple from DT. Notice how far the spoke protrudes past the top of this nipple. Here we have a 12 millimeter standard profile nipple from CN spoke. Notice how the spoke protrudes only a thread or two past the top of the nipple. Here we have a 14 millimeter standard profile nipple from CN spoke. This time the spoke stops right at the top of the nipple. Here we have a 16 millimeter standard profile nipple, manufacturer unknown, and notice how in this case the spoke stops just a hair shy of the screwdriver flat. In the next 5 examples of nipple and thread behavior, I retained the same nipples used before, but this time around I used spokes that were cut and rolled off of a Koa spoke cutter, which puts on about 10.5 millimeters of threads. This time around, when I used the low profile 10 millimeter nipple from Echelon, the spoke pokes through another thread or two. This time when I used the 10 millimeter standard profile nipple from DT, once again the spoke pokes through an extra thread or two. Moving on to the CN spoke 12 millimeter standard profile nipple, same thing happens. The spoke now pokes through an extra thread or two. Moving on to the 14 millimeter standard profile nipple from CN spoke, same thing. Now the spoke pokes through another thread or two. And the behavior repeats itself when we move on to the unknown 16 millimeter standard profile nipple. Now the spoke has poked through another thread or so. So there you have it, a demonstration of nipple and thread behavior, first using box threaded spokes with 9.5 millimeter threads, and then later using custom cut and rolled spokes with 10.5 millimeter threads. Here are some rules and thumbs regarding nipple and spoke threads. 1. More threads on the spoke equals liberal threading. Number 2. More threads in the nipples equals restrictive threading. Watch out for number 2, more threads in the nipples. Not all standard profile nipples behave the same. Some will be more restrictive. You need to watch out for them. Bottom line is, always test your nipples and threads. So how does nipple and thread behavior influence rim diameter or effective rim diameter? Here's a chart to help you out. On the left-hand side, I show a 10 millimeter standard profile nipple with the spoke protruding past the top, and then I have a red arrow indicating an aiming point. Why the difference? I, as a wheel builder, want to make sure that when I build a wheel, I can achieve optimal tension without running out of threads. The reason you aim a little lower is to give yourself some thread overhead. With a Mavic Open Pro 700C road rim, aiming for the top of a 10 millimeter standard profile nipple, as shown there, my effective rim diameter is going to be about 605 millimeters. And I'm sure you've heard that number elsewhere before. However, if I switch to a standard profile 12 millimeter nipple, now I'm having to aim a little lower because the spoke doesn't go as high, and therefore I got to drop my target down a little bit to maintain that 1 or 2 millimeter overhead. When I do that, my effective rim diameter now is closer to 602, 603 millimeters. The same adjustment occurs with standard profile 14 millimeter nipples, just a little bit, and then again with standard profile 16 millimeter nipples. However, using 16 millimeter standard profile nipples on short threaded spokes is not my cup of tea, because when you're aiming that low to maintain your overhead, you're barely engaging the head of the nipple. The more you engage the head of the nipple, the better the fastener arrangement that you have created. But if you want to do that, your effective rim diameter is going to be closer to 600 millimeters. I hope this chart helps you understand the point that I'm trying to make. Thank you for watching this video. If you have any comments, questions, or suggestions, you can visit my website at www.mrrabbit.net. Follow the link for Wheels by Fleming, and on the Wheels by Fleming main page at the bottom is my email address. Use that to shoot me an email.